Hi guys, welcome to the 7th video of module 8, and here we are going to build the model and then compile that model that we have built. So we are going to build this model with the help of Tensorflow and Keras framework, and then we are going to understand something called as parameter calculations with the help of model summary. We have done this in the previous module where we had created this architecture from scratch, how to calculate parameters over there. Now the same thing I'll be showing you over here, that how you can do this with the help of model summary. After that, we are going to compile the model where we'll be telling the model that what type of cost function, optimizer, and along with that, what type of evaluation matrix that you will be using for compiling the model. So yes, everything is covered in this video. So let's get started. So in the previous module, you had seen that how we can build the network from scratch if we want to. And even that particular way was not the optimal way, but just one way through which you can build your own neural network. Now let's say if you want to build very efficient neural networks in a very easier way without doing all that kind of code. So just like what we used to do in the sklearn to build different kind of models, like let's say from the linear regression or maybe the logistic regression. Very similarly for the neural networks, we mostly use this kind of frameworks like Keras or let's say PyTorch. PyTorch is the very recent one, but right now we are using the Keras, right? So the way that we need to build our model over here is to first of all identify that how we are going to add layers of the network over here. So I am going to use the sequential class. You can also use the functional way of building the whole model if you're aware about it. But the sequential class is going to ensure that all the layers are attached in a particular sequence. That first we have the input, then we have the hidden layers, and then we have the output layer. So if you are able to maintain this sequence, you can add all of these layers in a sequential way with the help of the sequential class. Now, what type of layer am I going to use? I am going to use only one layer called as dense layer. There are multiple other layers like convolution layer, max pooling layer, so on and so forth. Right now, our focus is to build a vanilla neural network or let's say multi-layer perceptron. For that, the only one type of layer I require is dense layer. So I'll be importing all of them all together over here. So I'll say that from Keras import, I should say Keras dot models, import a sequential, and then from Keras dot layers, import dense. And if I run this code, I have successfully imported this sequential way of building the model. And then I'm going to add one type of layer called as dense in my architecture. So both of them are imported over here. Now this is the type of architecture that we are going to create. That is, because we are having 15 different columns, I'll be having 15 input neurons. And because this is a multi-class classification with 3 different classes, I'll be having 3 output neurons in the output layer. And I'm coming up with this 3 hidden layers, which are again called as dense layers over here. And even the output layer is called as dense layer, by the way. But in these 3 hidden layers, I am coming up with some different number of hidden neurons. You can always experiment with this. That's what is called as black box model, because we are not really sure what kind of how many hidden layers or how many hidden neurons are going to work the best. A typical scenario over here would be that if there is a lot of difficulty that your model is facing, in order to find this kind of patterns between the input and the output, then you can increase the total number of hidden layers in between. According to me, 3 layers should be good, and I would come up with this kind of 64, 32, and 16 neurons for each and every respective hidden layers. You can always experiment with this, as I mentioned, and that's going to be more than enough. So over here, as we are having 15 features, so yeah, the same kind of things I've mentioned. And now it's the time to create the whole model with the help of the sequential class that we had imported and the layer that is imported as dense. So I just mention over here as sequential and instantiate this model over here. And now to add the layers, I just need to provide the name of the layer and then how many neurons per layer. So in my first hidden layer, I am having 64 neurons, but then you might be asking where is the input neurons, right? So we give this input dimensions over here with the help of input dims, and over here we can give this as 15. And one more thing I need to give is the activation that I'm going to use. So I'm going to use rel. In the second dense layer, I'll be using 32 neurons, But now I don't need to give any kind of input dimensions because the sequential API automatically understands. So the only one thing that I'll need to add over here would be the activation. So activation will be again value. And in the last hidden layer, I'll be using dense again, but now 16 neurons again with the activation is equal to ReLU. But now in the last layer, it is not the hidden layer, but even for the output layer, we are going to use the dense layer. Now we are having only 3 neurons, and this time the activation will be softmax. Because we are dealing with the multi-class classification, the final output will have the activation of softmax so that we are able to get the probabilities for each and every class. And after this, if I want to print the model summary, I can simply do model.summary and run the code. And there is a problem over here, and the problem says that input dims is not recognized. So there is a problem with what exact input will go over here. So I'll just press comma, and let's figure out what is that input that we need to pass in over here, right? So we need to pass in, there are multiple ways again through which you can pass the input. For example, there is a layer for the input if you want to use it, but I'm looking forward to the implementation of the input dimensions over here itself. So let's see where it is. Where it is. Where are you, bro? Where are you? I guess I'll just basically try it with this dim because I'm sure it's going to be either of them. Let's run this. Yes, it's working fine now. And over here, I'll just do this model summary. And even this is working fine. And now comes this parameter calculations, that how do we calculate these parameters that we have got in the summary of the model. So the first layer is connected with the input layer. So that had 15 neurons and then 64 neurons in the first hidden neuron. So if you do this mathematical calculation over here, that is 15 from the input, 64 in the hidden, that makes it a total of 960 weights, plus you have one neuron not neuron, but the bias associated with each neuron in the hidden layer. So there will be 64 biases, one for each neuron. So 64 neurons, therefore 64 biases. And therefore we got 1024 as the final parameter. Just like this, if you try to do this kind of connections, let's say if I want to calculate how did I get this 51. So I know that this 16 neurons will be connected to these 3 neurons. As you can see over here, this 16 neurons will be connected to these 3 neurons. So how many weights will be there in total? You can do the exact same process, 16 into 3. And then 3 neurons bias. So the output is 51. So that's how you can understand about this parameter calculations over here. And on top of this, I hope that this output shape is pretty much clear to you. That because we had used 64 neurons, that's why we are having the 64 over here. 32 in the second dense layer, so that's why 32 over here, so on and so forth. And after this, we are having the compilation of the model, in which we specify 3 different things. The first one is the optimizer, that is the cost function or the loss function, and then the metric that we are going to use in order to evaluate our model. So for the optimizer purpose, we are going to use the optimizer called as Adam, which is made with the concepts of gradient and momentum. After that, the cost function that we're going to use for the multi-class classification is the categorical cross entropy. Now, how I had explained you about the binary cross entropy or the log loss for the logistic regression for the binary classification problem, just like that we are having this categorical cross entropy, which works in a pretty much similar fashion for the multi-class classification. Now, the metric that we're going to choose over here would be the accuracy. Now, if you ask me, is accuracy really going to help because of the imbalance in the data? The answer is no. We need to use metrics like, let's say for example, F1 score, recall, precision. However, I'll be getting you the confusion matrix by the end of this particular module, so it's not going to be a problem. So we can stick with the accuracy as of now. So to start with the optimizer part, I can also give the direct name of the Adam optimizer, but now because I want to add this kind of learning rate to it, I'll be using Keras dot optimizer and dot Adam, and over here I'll use learning rate is equal to 1e minus 3. After this, I'll be using a loss as categorical cross entropy. And for the metric part, we can give it with the help of list. If it's more than one, even that is going to work. So accuracy is what I'm going to give. And I just need to pass in the comma parts over here and over here. And we did not import Keras anywhere. So I just import Keras. And then bus finally I'll run this code. Okay, the problem over here is, let's see, Keras is not defined. I have imported the Keras over here, right? K-E-O, yeah, spelling is incorrect. K-R-S. Hey, what is the issue? Keras has no attribute optimizers. Oh, all right. Not the problem. Now it works fine. It gives us this kind of warning, but it's completely fine. It's with respect to the deprecated LR. It's just going to help you understand that you can use the learning rate over here instead of just the LR. So learning rate is what I'm going to give as an input. And I guess we are pretty much fine. I'll just rerun it. That's the end of the video over here, guys. I hope you all are enjoying this process, that how easier it is to build and compile this kind of model in just one lines of code. Unlike the previous module where we had created everything from scratch. But yeah, that's the power of using TensorFlow and Keras framework. And just to let you know, guys, that there are also frameworks like, let's say, for example, PyTorch, also available to do the same task. But yeah, throughout this whole program, we are going to focus on TensorFlow and Keras itself. So yeah, that's about it.